In 1841, engineers powered America's telegraph network. They used nothing but scrap metal buried in dirt. By 1958, this technology had vanished from every engineering textbook in the country. Americans spent over $100 billion a year on electricity. The device you're about to see costs $0. It runs on zero fuel. It generates power indefinitely from soil, zinc nails, and wood ash. The electrical utility industry has no interest in you learning this. By the end of this video, you will know exactly how to build an 8-cell enhanced earth battery. It charges USB devices. It powers LED lights. It runs a radio permanently, using materials you can salvage from any demolished building. To understand why this was buried, you need to understand what it actually is. Welcome back. If you are new here, this is what we do. We find historically documented, scientifically verified knowledge that disappeared from public education. We figure out why it disappeared, and we make it usable again. This is not a conspiracy channel. This is a knowledge recovery mission. Every technique we cover was either patented, deployed at industrial scale, or validated by peer-reviewed science. Usually all three. If that matters to you, subscribe. Not for entertainment. For information you will not find in any classroom built after 1950. Because someone decided you did not need it. Let us go back to where this started, and where it was taken from you. The 1840s were the dawn of electrical communication. The telegraph was spreading across the United States and Europe at extraordinary speed. And it had a problem. Every telegraph station needed a power source. In cities, that was manageable, but the American frontier stretched thousands of miles through territory with no infrastructure, no supply lines, and no technicians. You could not ship batteries full of sulfuric acid to a relay station in Montana. You could not send a chemist to maintain them. The system needed something that worked with whatever was already in the ground. Enter the earth battery. The concept was simple. Bury two different metals in moist soil. Connect them with wire. Electricity flows. This was not theory. This was not a laboratory curiosity. This was patented, deployed industrial technology. Alexander Bain received one of the earliest patents for earth battery telegraph systems in 1841. The technology spread rapidly because it solved an impossible logistics problem. Remote telegraph stations across the western United States, across parts of Europe, across frontier rail lines ran on earth batteries for decades. Not days, not months. Decades. These systems required no acid, no chemical resupply, no trained operators for maintenance. A station manager could bury copper and zinc plates in the soil outside the building and power a telegraph relay indefinitely. The materials cost almost nothing. The installation took hours. The power generation lasted years. This was standard infrastructure, not an experiment, not a prototype. Standard, deployed, revenue-generating infrastructure that kept critical communication networks operational across an entire continent for over 50 years. From the 1840s through the 1890s. And then it was gone. Not classified, not restricted, not disproven, just gone. Removed from engineering curricula, absent from physics textbooks, missing from every electrical education program in the country by the middle of the 20th century. A technology that demonstrably worked for half a century simply stopped being taught. So what happened? How does a technology used across an entire continent for 50 years just disappear? Hold that question. We will answer it. But first, I need to be honest with you. What you're hearing in this video is the surface of the research behind this channel. Behind the scenes, we have compiled an extensive library we call the Vault. It covers grid-down power generation, water purification from raw sources, long-term food preservation without refrigeration, medical alternatives when pharmacies are empty, and communication systems that work when cell towers do not. Every single item is historically documented, scientifically explained, and practically buildable. No fluff, no filler, no theoretical speculation. If you want access to the full depth of what we have compiled, the link is in the description. But everything you need for this specific build is right here in this video. You do not need to go anywhere else. Stay right here. Now let us talk about why the version you have heard of does not work, and what changes that. If you have ever looked into earth batteries before, you probably saw someone stick 2 nails in a potato, or bury some pennies in aluminum foil in a garden, and you probably measured something pathetic. Maybe 0.2 of a volt, maybe 0.3. Barely enough to register on a cheap multimeter, certainly not enough to power anything useful, and you probably walked away thinking the whole concept was a joke, a science fair trick, not a real power source. Here's what they left out. The earth battery works on a principle called galvanic corrosion. This is not fringe science. This is chapter 4 of every electrochemistry textbook ever printed. When two dissimilar metals are placed in contact through an electrolyte, a liquid that conducts ions, electrons flow from the more reactive metal to the less reactive metal. That flow of electrons is electricity, period, no debate, no controversy. Textbook physics that every electrical engineer on Earth accepts without question. Zinc is highly reactive. Copper is not. When you bury zinc and copper in moist soil and connect them with a wire, zinc atoms give up electrons. Those electrons flow through the wire to the copper. That is your electrical current. The soil acts as the electrolyte, allowing ions to move between the electrodes underground while electrons travel through the wire above ground. Here is the problem. Plain soil is a terrible electrolyte. The ion concentration is low. It is inconsistent. It varies with mineral content, moisture level, temperature, and composition. That is why the science fair version produces almost nothing, not because the principle is wrong, because the electrolyte is weak. Now here is the specific piece of knowledge that was lost. Wood ash contains potassium carbonate. When you dissolve wood ash in water and saturate the soil around your electrodes, or the potassium carbonate dissociates into potassium ions and carbonate ions. You're flooding the soil with charge carriers. You're transforming weak, inconsistent dirt into a potent electrolyte solution. The result is a voltage increase of approximately 400%. Not 4%, 400%. A single cell that produces 0.2 of a volt in plain soil produces 0.8 to 1.1 volts in ash-treated soil. One cell gives you roughly 1 volt. Wire 8 cells in series, and you get 6.4 to 8.8 volts. That is enough. That is a real usable voltage range. Run it through a simple 5-volt regulator and you are charging USB devices. Connect it directly to an LED array and you have light. Hook it to a small AM/FM radio and you have communication, all from zinc, copper, dirt, and wood ash. The current is measured in tens of milliamps. That is not a lot, but it is continuous. 24 hours a day, 7 days a week. No fuel, no moving parts, no maintenance beyond occasional rewetting. Milliamps multiplied by infinite hours adds up. So you have a technology that works on textbook physics. It was used industrially for 50 years. It produces 4 times more power with one simple enhancement. The question is not whether it works. The question is why you were never taught it. Let us follow the money. The United States electrical utility industry generates over $100 billion in revenue every single year. The average American household pays over $100 per month for electricity. That is over $1,200 per year per household. Exposed wire running to a meter on your wall, measuring every kilowatt hour, billing you monthly, automatically, indefinitely. That is the business model. Metered consumption. Recurring revenue. Every single month, forever. In 1935, the federal government established the Rural Electrification Administration. Its mission was to bring centralized, grid-connected electrical power to every rural household in America. Through the 1930s, 40s, and 50s, this program expanded aggressively. Millions of homes were connected to the grid. Power lines were strung across the country. Utility companies were granted regional monopolies. Rate structures were established. Meters were installed. And during exactly this period, earth battery knowledge vanished from American education. I want to be honest with you about something. I cannot show you a classified memorandum from 1942 ordering the removal of earth battery curriculum from engineering programs. That document may not exist. The circumstantial case, however, is structurally compelling. You have a technology that generates free electricity indefinitely. It cannot be metered. It cannot generate recurring revenue. It requires no proprietary components. It cannot be patented because it has been in the public domain since the 1840s. It cannot be taxed because there is no transaction. It cannot be controlled because the materials are zinc, copper, wood ash, and water. Every single one of those is an unregulated natural or household item available everywhere on Earth. Now ask yourself a simple question. If you run a utility company generating billions of dollars in annual revenue from metered electricity consumption, what is your incentive to make sure people know about this? The answer is zero. Your incentive is precisely zero. Every kilowatt hour a household generates independently is a kilowatt hour you do not sell. There is no conspiracy theory required here. Just basic economics, just quarterly earnings pressure, just the structural reality that no corporation, no industry association, no government agency funded by utility tax revenue has any reason to promote a free, unmeterable, unpatentable power source. The military knows about this, by the way. Ground-based galvanic power sources have been studied for unattended remote sensor applications. When you need a sensor to operate in a remote location for months or years without battery replacement or solar panels that can be spotted, you bury electrodes in the ground. The physics works. The military has confirmed it works. They just never had any reason to tell you. Whether this was deliberate or accidental does not change what you can do with it right now. If you are still here, you are the kind of person who wants to know what actually works, not what someone wants to sell you. That is what this channel is for. If you have not subscribed, now is the time. Not because I need the numbers, because the next video covers something just as practical and just as buried. The link to the vault is below for everything else, but do not leave this video yet. Before we build this, you need to know what it cannot do. Well, I'm going to be direct with you because your trust matters more than your excitement. An earth battery will not power a refrigerator. It will not run a space heater. It will not operate a power tool or anything with a significant motor. The current output is measured in milliamps, not amps. Charging a phone will take many hours, not 1 hour. Performance drops in dry soil and drops further in frozen soil. You will need to re-wet your electrolyte during dry periods. The zinc electrodes corrode over time. That is literally how the device works. The zinc atoms sacrificing themselves is what generates the current. Depending on your draw, zinc electrodes last months to years before requiring replacement. And the alkaline ash solution will raise the soil pH in the immediate area around your installation. So do not build it in your vegetable garden. Now here is what it will do. It will provide the 3 most critical electrical needs in any grid-down scenario. Light, communication, device charging indefinitely for $0. For materials available in any demolished building, any burned structure, any scrap pile in the world. No supply chain, no fuel dependency, no expiration date. When the grid goes down and your generator runs out of gasoline and your solar panels are buried under debris or ash or snow, this still works. Quietly, underground, invisible, producing power every second of every day. Here is exactly how to build it. Materials. You need 8 zinc-coated steel nails, commonly called galvanized nails. 6 inches long minimum. You can pull these from any demolished structure, old fence, or pallet. They are everywhere. You need 8 sections of copper wire, solid copper pipe, or copper grounding rod. 6 inches of exposed copper per cell. Stripped copper electrical wire wound into a tight bundle works. Old copper plumbing from a demolished bathroom works. You need wood ash. Hardwood ash is best. Oak, maple, hickory. 1 standard 5-gallon bucket of ash is more than enough for 8 cells. You need water, roughly 5 gallons total. You need insulated copper wire for connections between cells. 18 gauge or similar. You need a 5-volt USB voltage regulator module. These cost under $2 and can be salvaged from any broken car charger or cheap power bank. And you need a multimeter for verification. Total material cost using salvaged components is $0. Step 1, prepare the electrolyte. Mix wood ash and water at a ratio of 1 part ash to 5 parts water by volume. 1 cup of ash to 5 cups of water. Stir thoroughly. Let it sit for 15 minutes. Stir again. You want a cloudy, grayish liquid. This is your potassium carbonate electrolyte solution. Step 2, select your site. You want soil that retains moisture. Clay-heavy soil is ideal. Sandy soil drains too fast and will require more frequent rewetting. Avoid rocky ground. Avoid areas that flood, which would dilute your electrolyte. A shaded area that stays naturally moist is perfect. Step 3, dig 8 holes. Each hole should be 12 inches deep. Space the holes 18 inches apart in a straight line. The 18-inch spacing prevents the electrolyte zones from overlapping, which would short-circuit adjacent cells. Step 4. Pour approximately 2 cups of your ash water solution into each hole. Let it soak into the surrounding soil for 5 minutes. Step 5. Place 1 galvanized zinc nail and 1 copper electrode into each hole. Keep them separated by at least 4 inches within the hole. They must not touch each other underground. Press them firmly into the wet, ash-treated soil at the bottom of each hole. Step 6. Backfill each hole with a mixture of the excavated soil and additional dry wood ash. Approximately 1 cup of dry ash mixed into the backfill per hole. Pack it firmly. Pour another cup of ash water solution over each filled hole. Step 7. Wire the cells in series. This means connecting the copper electrode of cell 1 to the zinc nail of cell 2, then the copper of cell 2 to the zinc of cell 3. Continue this pattern through all 8 cells. You will have 1 free zinc nail at one end and 1 free copper electrode at the other end. These are your negative and positive terminals, respectively. Zinc is negative. Copper is positive. Step 8. Test with your multimeter. Set it to DC voltage. Touch the red probe to your final copper terminal. Touch the black probe to your first zinc terminal. You should read between 6.4 and 8.8 volts. If you read significantly less, check your series connections. A loose wire or a reversed cell will drop your total voltage. Step 9. Connect your 5-volt USB regulator to the positive and negative terminals. The regulator will step the voltage down to a stable 5 volts for USB device charging. For LED lights, you can connect low-power LEDs directly to the battery terminals through an appropriate resistor. A string of white LEDs rated for 6 to 9 volts will operate continuously. For an AM/FM radio, connect directly if the radio operates in your voltage range, or use the 5-volt regulator for radios with USB charging. Step 10. Maintenance. During dry periods, re-wet each cell location with 1 cup of ash water solution, every 3 to 7 days depending on your climate and soil drainage. In consistently moist climates, you may go weeks without needing to add solution. Monitor your zinc electrodes every few months. When a nail has corroded to half its original thickness, replace it. Drop a new galvanized nail into the same hole with fresh ash water solution. Your copper electrodes are effectively permanent. But copper is the cathode in this system. It receives electrons. It does not corrode significantly. Your copper will outlast you. What does this look like in practice? 8 nails and 8 pieces of copper in a line in your yard. A wire running to your window, a small regulator box, a USB cable, your phone charging, your LED strip lighting your kitchen, your radio pulling in AM stations, all running continuously. No fuel, no noise, no moving parts, no monthly bill, no grid connection, nothing to break down, nothing that can be turned off by someone else. You now know something that was standard knowledge 100 years ago, knowledge that has been absent from every textbook since. Let me put this in perspective for you. This technology was patented in the 1840s. It powered telegraph networks across the United States and Europe for over 50 years. It was enhanced with wood ash electrolyte to produce 400% more voltage than plain soil. It vanished from public education during exactly the period when the federal government was spending billions to connect every household to a metered, taxable, profitable electrical grid. It was never classified, never restricted, never disproven. It simply stopped being taught. Whether that erasure was deliberate policy or natural obsolescence driven by economic incentives does not change the outcome. The result is the same. An entire generation lost access to a free, permanent, buildable power source that works on principles no scientist on Earth disputes. Galvanic corrosion is real. Potassium carbonate conductivity is real. The historical deployment record is real. The voltage readings on your multimeter will be real. Now you have it back. Share this video with someone who needs it, not for views, not for engagement metrics. Because this knowledge spent 60 years being forgotten, and the only reason it comes back is because people like you pass it on. The next video in this series covers a method for water purification that was standard practice in 3 ancient civilizations and cost less than $1 to build. It is in the vault. The link is in the description. They can make you forget. They cannot make it stop working. 8 nails in the dirt. That is all it takes.